And I am live and also audible. That is pretty nice. So today is, as you might know, 24th of September 2025, Wednesday, and today is also a contest. But the timing of today's contest is a bit different. It is going to be in the middle of the day, like in evening, not middle of the day, a bit after the middle of the day at 5 p.m. here, IST, Indian Standard Time. So, but I have higher chances of being getting disturbed. Look at this. Look at this. I am a contributing member of the society. I have some positive contribution. All right. I am a big boy now. I have some contribution. Shit. People did read my blog. That is nice. These things are just syntactical sugars. 40, 54. And I want to show you something. There is this guy. Shit. That is a lot. Shit, I haven't read this comment. That is nice. Peltorator. He has a YouTube channel and he has videos on things, like long videos on things, and that is nice. He commented on my post, so that is nice. Shit. He said, why is it called syntactical sugar? Because we are only using the standard operators, but these operators don't mean anything internally. There is a function call which these operators are evoking, like this one right here. So yeah, that's why they are called syntactical sugar. But that is nice. Like people are engaging, and I have some contribution now, positive contribution. Look at this. That is pretty nice. And yes, today's contest is going to be in like not at the right time, so I won't be giving today's contest. And with that, let's start doing questions. Count subrectangles. There are how many questions are left here? 1, 2, 3, 4, 5, 6. Let's do 5 if I could. Okay, if I could, I will do 5 questions. It is 11, 26. 1, 2, 3, 4, 5. 5 questions. I will stream for at least 3.5 hours. And I will see if I can do 5 questions. That would be nice. And one more thing. I have been good at DP at this point, but not at graphs. There are some things like, yep, graphs. I have to go deep down with graphs like I did with DP, and yes, I'll do that after 1500 rated questions are done. So that would be nice. Stopwatch and shit. The things outside changed their size, not this. Remix it. And why am I in the config folder? BCP CD 1500 in the other window also 1500. Vim. Yep, everything is fetched up. We can start solving the question, and that would be pretty nice. Let's get on with this. Start. Okay. Count subrectangles. You are given an array A of length n and array B of length m, both consisting only of 0 and 1s. Okay, binary arrays, strings. Consider a matrix C of n by m, where n is the number of rows, m is the column. Following the rule, I is in the ith element and B is in the bth. Wait, have I done this? I very much feel like I've done this, but okay. Okay, that is AI multiplied by BI multiplied by BI. So that is just their and taking their and because they are 0 and 1s. It's easy to see that C consists of only of zeros and ones too. Yes, how many subrectangles of size area K consist only of ones are there in C? Should I feel like I have done a question very similar to this one in one of the previous contests? And a subrectangle is an intersection of consecutive subsequent segments of rows and consecutive subsequent segments of columns that is considered four integers x1, x2, y1, y2, where x2 is greater than equal to 1 and x2 is also there. They are between n and y is between m. A subrectangle. This is an intersection of rows from x1 to x2 and columns from y1 to y2. The size area of a subrectangle is the total number of cells in it. So I have to tell how many subrectangles of size k are there in such a matrix where I am taking their and. Okay, so I have n, m, and k, and then the array A and then the array B. That is nice. So since I want the area to be equal to k, what do I want? I want the area to be equal to k, right? I want the area to be equal to k. And if I have something like this, and I need internally something rectangular in any way like this, some rows and some columns and some rows, if I multiply them, their area should be equal to k, and does not this orientation and the particular size of this block does not matter as long as it is a rectangle and the size is k. And since I want everything internally to be equal to 1, this would only be possible if everything here is 1 and everything here is 1. Only then I will get all the ones here. Otherwise, there would be a 0 or something. So I just need to find the since I have two vectors, vector A and vector B, I need to find the lengths of sequences in B which have only ones, and same for A, just the length of sequences, and C, if I multiply this by this by this, or no, I don't have to exactly multiply. I have to look in B how many sequences there are, which let's say the length of this in A, let's say in A there is A1, A2, A3, and these are not like the first element in A and the second element in B. These are A1 is, let's say, some number which is the size of a subsequence in which, not subsequence, size of a subarray in A which only has ones. So we have a subarray of size A1 where every element is 1, and a subarray of size A2 and a subarray of size A3, and these are separated by 1 or multiple zeros. And we have same for B1, B2, B3, and what we need is their area to be exactly how many subrectangles of K consisting only of ones are there in C, exactly the size K. Here we want size to be equal to 2. Okay, in here we want size to be equal to 2, and here we can see if we are calling this one A and this one B, here we have a subsequence of size 1 which has only ones, this one, and a subsequence of size 1 which has only ones. So we have two subsequences of sizes 1 and 1 each, and here we have a single subsequence of size 3, and we want the target area to be equal to 2. Now I need to see how for this one, how many, yes, I have to go through all of the subsequences. I need 1 to be multiplied by 2 to have a area of 2, which is k, which is the target area. And I see that in B, among all the subsequences, there is this one subsequence which has a size of 3, which is either equal to or greater than 2, which is needed to be multiplied by 1. So here from 3, how many different ways can I, since the size of the subsequence in B is 3, 1, 2, 3, how many different ways can I choose a subsequence of size 2? That is that is just 3 plus 1 minus 2, I think. Yes, 3 plus 1 minus 2, because one subsequence is this and another is this. So in total, I have two subsequences for this one. So 2 for this one, and then for this one, same thing, plus 2. So answer should be 4. For the first one, it is 4. Okay, let's also go for the second one where the size is supposed to be 4. And shit. This is permutation and combination. Shit, this is more complicated than simply doing this, because here, wait, shit. Okay. Since I want target to be 14, 14 could only be achieved by 1 multiplied by 14, right? Cool. And then 2 multiplied by 7, and yes, okay. And let's go all the way, 7 into 2 and 14 into 1. So let's go for 1. How in, like, on average, every number, let's say, has log n factors. So in total we will have log n size of this thing, and that is okay. And for every log n, we will see how many ways can we make this combination possible. So how many subsequences are there in 1 of size 1 which have only ones? Well, there are 3. There are 3 on the left, and on the right in blue, and like B array, how many subsequences have a size of 14 which consist only of ones? 0. So here the answer is 0 for this combination. And then for this combination, how many subsequences there are in 1 in A which has a size of 2? There are 2 subsequences, this one and this one. So 2 multiplied by how many subsequences of size 7? 0 again. So the answer is 0. And shit, the answer is always 0. Shit, I guess I messed up. Yes, k is equal to 4. My bad. K is equal to 4. Hello, good afternoon. No, I won't be giving today's contest because it is at a bad timing, and I might have to get up at 5. So like I won't be completely present because I might have something to do. So I won't be giving today's contest. But what I have planned, since I do not want to like just make an excuse and not give a contest, tomorrow, in tomorrow's stream, I will give a virtual contest for today's contest, and I won't look at the questions. Tomorrow I will be giving the virtual contest as if I am like giving it for the first time, because I won't look at the questions. It would be nice. Shit, I messed up a little bit. So our sequence is 1 1 1, and here we have 1 1 1 1 1. So yeah, I guess I should just implement this, and I will like get into the abstract details later. This makes sense actually. N, M, and K, N, M, K, and 40,000, 40,000, 40,000. Can this go till N square? Almost. Yes, we can go N square. That is fine. And K is always smaller than N into M. So K can be big. We take all of these, and vector int. I'm pretty sure we don't even have to save these, but anyways, int I equals 0 for interreference x a c in x, and for interreference x b c in x. And now vector int sub a, as in like the subsequences in a which are only ones. And to calculate that, we have a very special method from Mr. Jiangle. L equals 0 initially and r also equals 0, and this will go till r smaller than n and L equals r at the end of each loop. And what we will do is, while al equals a r, we will do r plus plus. And after this, r is pointing to some element which is not equal to the starting element. And now what we have to do is, if al equals 1, that is what we are looking for, then sub a dot pushback. And one more thing here, r is smaller than n, dot push back the size of this thing, which is r minus l. And that is it. We have this sub a fully filled. We will also have sub b, which sounds a bit crazy, like sub b. And here we can replace this a with b, and that is kind of it. So we have the subsequences now, and that is cool. Now we have to factorize k. How do we factorize k? We could, if we want, do a like optimal approach, but we don't actually have to. We can, yes, we don't have to. Uh, Vector pair int facts for int I equals 1, I less than equal to k square root of k and I plus plus. And k if k is completely divisible by I, then I is a factor of k. And what we will do is facts dot push back I and k by I. Now we have all the factors, and we have to now find a way. I think we don't even like, yeah, we don't even have to store this. We can just do this on the fly. And x and y equals, we will call x equals I, and y equals k by x. These are factors. And now we have to see how many subsequences in A have a size greater than or equal to I, for which we can, after this, sort sub A dot begin and sub A dot end, and the same thing with B. Both of these are sorted, and we are looking for, first of all, we will look for x in sub A and y in sub B, and long answer initially is 0. Yes. Hello. Yes. SSLAR. That is crazy. SSLAR. I don't know what that means. So what we need is a iterator. auto it equals lower bound, that is what we need, lower bound and sub a dot, this might not be very optimal, but yeah, this is op okay. In total, root k, so under root n, that is fine. And for each under root n, we are going through, let's say, n time complexity at the worst, in the worst case, and that is okay. That is okay, actually, okay. Genuinely okay. I'm just joined BTech. Can you tell me the things to do, be good in position in future? Yes, you can. Since you are a beginner, you can start doing CS50. Let me stop the timer for a minute. I'm gonna start doing CS50. This is a very nice course and one of the best thing you can do as a beginner on edX. This is a course by Harvard University and this is free, and this not just tells you how to write code in a certain language, but how to think like a programmer, and that is pretty nice. And this is for introduction. Wait, this is the one. CS50's Introduction to Computer Science. That is the one you can take, and the teacher is also pretty amazing. You can go and take this course. Pretty nice. And now back to this question. Look for x, right? And if it is not equal to sub a dot end, then auto it2. Uh, Lower bound sub b dot begin and sub b dot end, look for y, and if it is not equal to an and it2 is not equal to sub b dot, and if none of them is equal to end, then okay, then end uh, the number of subarrays in A of size x or of size x, and the number of arrays in subarrays in B of size y. That is what we need to find. So we can NA number in A and NB number in B equals 0 in the start, and then while it is not equal to sub a dot end, or we don't even have to do that, we can just do this here directly. While sub a is not equal to end, what we will do is NA plus equals the value, go to it plus 1 minus k, not k minus x, right? And while it is not equal to sub b dot end, and b plus equals, go to it plus 1, go to it2 plus 1 minus y, it2, and answer plus equals number in A multiplied by number B. And now we turn the tables. Lower bound, we will look the lower bound for the same numbers, but now x and y are reversed, and the same logic again, but for the reversed numbers. Instead of x, we have y, and instead of y, we have x. And answer is incremented. And that should actually be good enough. See out. Answer. Square root was not declared in the scope. Where is the square root function? You're welcome. How much time will it take to complete that course? I will begin again after you complete the course. Thanks. Okay, you can come again, of course, and do not think about how much time it is going to take because you are just a beginner, and as much it would be as good. Focus more on the quality and not the time is spent. If it is taking you 10 hours of work to get a like very small topic correctly in your mind, then give it 10 hours. Do not focus on the time at the start, just focus on the quality of your understanding. If you have to watch a lecture again and again multiple times, then watch the lecture again and again multiple times. LSP start, Clang D, and we do not seem to have math. Yes. What is it called? Math.h. Okay, it is a C library, not a C++ library, it seems. Out of bounds. Crazy. Okay, because of this thing right here. This has to be M, and this also has to be M, and okay, we should be happy now, hopefully. Okay, it is still running and it is not stopping. Yes, it is not stopping. Shit. Think. Okay, I think this part is correct. Whole part till this point, and after this is also correct. And here we have I less than square root of k, that is also correct. So mistake has to be again in this part, but I'm doing push back. Sub A, sub B, yes, pretty cool. Okay, let's see. I do take in here X, A, and B. That is okay, nice. B count dot slash out. What is the question? Question is this. Oh, it is still running. It doesn't stop. That is crazy. High dot slash out 332 101 111. High. Okay, so we are getting past this point. That is nice. But I guess we are not getting past this point somehow. Here we have, of course, we are not getting past this point because iterators are not iterating. Makes sense. Makes so much sense. So LSP stop. I think now we are not very okay. Okay. We can remove the high and okay, shit, I am stupid. Makes sense. We do not have multiple test cases. We only have a single test case, so we don't have to take in T or anything, and that is just a mistake I have made multiple times. Correct answer. Wrong answer. Wrong answer is bad. Yo, let's go. Wrong answer is bad. Wrong answer is not good. A, B. Okay, let's see out A sub A and sub B. 25 POV. Shit. 113. That is good. And 3 and 5 is very, very good. So why is the answer 22? Is there some logical mistake apart from the implementation? Here, 3 and 5 is good because here we only have one sub array of size 3 and here we only have one sub array of size 6. 5. 1, 2, 3, 4, 5, 6. This is supposed to be 6. Why does the program says it is 5? 5 is not good. Yep, 5 is not good. R plus plus while M is smaller than M is 6, right? M is 6. 1, 2, 3, 4, 5, 6. And if yes, if R does become equal to M, we will like get out and 6 minus 0 will be 6. So 6 should have been added in the list, but it was not. And if we do like illegally, manually change the first value to be equal to 6, I expect to see the correct answer now. Or maybe not. Shit, my bad. 5. This 5 is wrong. This 5 is wrong. 3 is right because we have a subarray of size 3 and 5 is also right. Shit, my bad. Shit, it is 5. 5 is correct. So what is the mistake? We need 4. So for 4, makes sense. Okay. I messed up. Now I know. Do this second step after this. If x is not equal to y, only then do this second step. Because if k is a perfect square, we do not want to look for the same element twice and add the answer twice. So this is correct, and this is correct. This is correct. And the whole thing seems to be correct. Seems like we did it. Okay, that is cool. And now we are going to do some pro level thing, and that is delete the whole code and write it again from scratch before submitting it. That is just what a good programmer does. X, because he has confidence in himself that he can write the code again, and we want to become good programmers. So we copy. We have n and m vector in n, a size n and b size m, and for int reference x in a, c into x, for int reference x in b, c into x, We have x and b, and now we will create another vector of integers sub a sub a and 1 sub b, which will contain the sizes of subarrays. And yes, then we need to fill them. And for filling them, we have the legendary OP method, which was given to us by Mr. Giangli. There's an n, L equals R, and internally while AL equals AR, R plus plus. And if AL equals 1, then we will add it to our subarray. Sub A dot push back, back, back R minus L, and that is kind of it actually. And we will do the same thing for B. Fn, replace this by M, and also one more thing here, R has to be smaller than N. Only then will we index A with the value R, and here we will be indexing B. And B. Okay, and here R has to be smaller than M. So sub A and sub B are sorted, on filled, not sorted. Sub A dot begin, sub A dot end, and sort sub B dot begin and sub B dot end. And now answer long, very long, not this long. Answer equals 0. Now for factors, the possible ways to get a product of k. For int I equals 1, I less than equal to QRT, square root of k, and I plus plus. If I is a factor of k, which would be when I does not give any remainder, we will have int x equals I and int y equals k by I, like the two factors which the two numbers which multiply to give us k. Now auto iterator, we need to find out how many sub arrays in A have a size equal to k, exactly equal to k. Say find the lower bound in sub A dot begin, and let me put my my laptop on do not disturb so that no one calls, and we go like lock in mode sub A dot end, and we are looking for something called x, and iterator 2 the same thing, but sub b we are looking for in the sub b vector, and sub b dot end, and we are looking for y here. Now number in A and number in B, okay, we can call them that. Here also put them equal to 0, and while it is not equal to sub A dot end, we will increment na plus equals the number here, the size, that is go to it plus plus. We will also increment the iterator by 1, it plus 1 minus x, because we are looking for subsequences of size x, and while it2 is not is not equal to sub dot b dot end, number in b nb plus equals go to it2 plus 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 1 minus y. That is nice. And answer plus equals na into nb, and B. And now if x is not equal to y, that is, if we are not at a perfect square number, then we might also like to look for subarrays of size x in K and subarrays of size y in subarrays of size x in B and subarrays of size y in A, which is just the opposite of what we looked for there. Lower bound, replace x with y and y with x. That is going to be the only uh, change, but also this, we don't want to declare the same things again. Look for x, y, yeah, y, x. And at the end, see out answer. Square root is not included. Let me fix that from the root. Cd dot local slash include and bits slash std c plus n std c plus plus dot h. Include maths dot h. Is it maths or math? lsp start clang d math dot h. Okay, lsp stop emacs attach tcp. We are back here. It is working. It is working, and I think it is going to be very amazing. We can copy and submit and see how we did. It is submitted, and let's see how it goes. Okay, 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 okay. That is good. That is good. That is good. 37 minutes. 37 minutes is a lot of time. And this question was simple. I won't say very intuitive. It was a bit intuitive, but not worthy of 30 or 38 minutes. That is a lot of time for this question. So this is bad. This is not worth celebrating. 38 minutes is a lot of time. Nah, shit. 38 minutes is actually a lot of time. If I am in a contest, I won't be able to solve 4 questions at this speed. If all of them are at 1500 rating, supposing that this is the lower limit. 38 minutes is bad. Not good. Let's read the editorial. Before that, let me predict or guess. Predict is not the right word. Let me guess the tags. The tags are going to be maths. I think tags will include maths, uh, maybe geometry, implementation, and maths are the 2 things I'm saying. Implementation and maths. Let's see. Or maybe none of those things. Greedy. Okay, implementation is here. Binary search, yes, I am using binary search, lower bound, and sorting. That is nice. Those things just like don't even register at this point. Like I am using binary search here. It just feels like addition. You don't write addition as one of the tags, right? And look at this. This is just amazing. I am a contributing member of the society now. What is this, bro? What are you preparing for? I am preparing to be one of the best programmers. And like, yes, I'm documenting everything. And I want to show you guys that this is not something special. You can do this also. Like, you can go and watch my past streams where I was very bad. I'm not still not very good, but I have grown a lot. And you can see the whole like transition which is going on right now. It's so intense programming though. It it is feeling it might feel very intense to you because of course it is feeling very intense to you because you might be watching competitive programming for the first time, and a few months ago this thing would also feel very intense to me. But I've been doing this for like 87 streams at this point, and now like this does not feel intense because I am actually doing it. So this will not feel intense to you if you have given it a few months. And all I want to show through through these streams and my channel is that anything can be conquered if you are just after it again and again, day after day, and you can become one of the best. Like, yes, I think anyone has the potential to be one of the best. Last time I used those BST and stuff during my exams in C++, I thought it was useless. No, it is not useless. It is not useless. It is, I do not think anything fundamentally is useless. No, no, it is not useless. And if like that is the mentality that I want people to get out of, that you are learning things for exams. Like, what is the point then if you are just learning something to get some good numbers in some exams? There is no point. I want people to get out of that mindset, because if you get out of that exam mindset, you will be actually learning. First of all, you will be actually learning whatever you are learning. And second of all, well, let's talk about more on the first point. First of all, you will be learning actually. Like, you will be genuinely interested in whatever you are doing if you're not doing it for the exam's sake, and you will love it, like really. And second of all, for C++, best tutorial name. And second of all, you will be doing more than what your exam is limiting you to do. And that is cool. Best free tutorial for C++. How can you learn C++? I don't... C++ is a very complex language. It would depend on, is this going to be your first language? And by the way, just saying we have two Manish here at the same time, that is amazing. And yes, this would depend on how much programming you have done before, because C++ is one of the most complex languages out there. And I would like to know how much programming you have done before. And if this C++ is your first language, then it is going to be very tough, and it would be hard for me to suggest any resources for a beginner who doesn't know about programming and he wants to learn C++. So what level of programming is this? I mean, is this physical level like TCP and stuff? No, no, this is just data structures and algorithms. You might be thinking about this. I did this tmux attached TCP. This is a program called tmux. There is a program called tmux, just like there is my browser. There is this program which I can use to have multiple sessions of terminal. And tmux means terminal multiplexer. And I want to attach to my session in which I'm doing competitive programming. And sessions are like windows. Like in this session, you can call this instance of my Brave browser a session, and here I have different tabs. Similarly, in terminal, I have this program called tmux and it has different sessions, and I want to open the window in which I do competitive programming. So I write tmux attach to the session, and the target T hyphen T is CP. CP is the name of my session where I want to connect, and now I am connected. And like in a browser, there are tabs at the top. Here in this session, I have windows at the bottom. One window for NeoVim, one for terminal. For terminal, now I am in this window shown by this asterisk at the end. Now I am in the NeoVim window, and that is nice. And I have multiple sessions. There is this CP session for competitive programming. For contests, I have another session for C++, DSA, CSES, and GDB. There are another sessions, and tmux is just away. Hello, I'm beginner, and it is my first language, C++. If okay, I would suggest you go and first learn some C. That would be nice. And if you want to learn C, I think the best way for learning C is through these lessons. CS50, uh, intro to computer science whole playlist. Yeah, I guess you can watch this.
Use the equal sign for
You can watch this thing, I guess. Yep. C programming language. This is by Harvard, like literally Harvard's course. I think you will be able to find more latest lecture than 2018, which is 7 years from ago. Shit, 2018 is already 7 years ago. That is crazy. I've started C++ just now. C++ is my first language. Okay, and if you have started, then just go with it. You would be able to do it. You have a GPT-28 on your side. I'm currently learning and doing small independent projects, Django, React, because around my place I'm not seeing vast future other than web. That is fine. That is fine. 6, 7. Uh, okay. Modi ji. Hello, I am new to CS. Do you have any recommendation for discrete structures? Discrete structures. Discrete structures. What do you exactly mean by discrete structures? I guess every structure is discrete. What would be a continuous structure? Every structure is discrete, right? Yes. Yeah. Every structure is discrete. And I wouldn't know any resource on this one, but yep. And this thing is good. Like we got this one. Okay. Okay, this one is now done. Now we can move on to the next question, and that would be nice, like really nice. How did you learn all these? I mean, what do you create with these, and what job opportunity is there with these skills? Enlighten me also, because you no, I am not currently working. I am currently in my third year, and no, I'm not working. Job opportunities, that is what I said. You do not, when I study, if I think about, if what I have in my mind is I have to study this because I want to get a job, I will not be able to study it like effectively, and I will forget what I have studied. So it is not very, like, for me, I cannot study if I'm thinking about getting a job. So I do not think about getting a job, and instead I just study. So I would say get out of this job mindset. And I'm not saying not getting a job is a thing, but while you are studying, do not think about getting a job. Just study. And job opportunities. Job, see, I'm doing this because this is one of the hardest things. As you can see, where is this amazing graph? This one. As you can see, I want to get to a rating of 2000. That is in the title of the video. And people at a rating of 2000, there are only 1.61 percentile. Like if you have a rating of like above 2000, you are about in top 2 percentile of people. So this is very hard. This is very hard. This is very difficult. This is very difficult. And if I can get a rating of 2000, everything else, web dev or anything else, would be very easy to do. So that is why I am doing DSA, because this is developing my brain and my capacity to think and conceptualize about things very immensely, and everything else will seem easier to me after I've done this thing. So that is why I'm doing this, and this subject is giving me a difficult time. Yeah, just if there is no structure, then just watch different videos on the topic, and initially they will not make sense to you, but eventually they will. Like, because if you are spending time with something, eventually it will make sense. You are passionate, finding passionate people in CS at this time where everyone is taking CS course. Just it's cool and awesome. Did you give JE and like that? Because I don't know. I'm not from India. Shit. Your name feels like you are from India, but okay. Yes, I did give JE and I went to a tier 3 college, and everything I've learned is not from my college, it is by myself. That is something. Shit. There is a specific word, autodidact. Uh, Didact, autodidact. Self-taught person, autodidact. Learn how to be a autodidact, a self-taught person. Da Vinci, like Leonardo da Vinci was a autodidact. He used to ask questions about everything that he saw, and we can see how further he got. And this passion, I do not like to call it passion. I have generated this curiosity on my own. It was not there, and the point is you can also do it. There is nothing special, nothing special. How to learn from question and how to ask, how to understand that this is important learning from question, which can be used further. You should be able to identify in a question, whenever you see a question, what is the essential concept, which, okay, if you are able to solve a question, then you know why you were able to solve a question. And if you were able to solve a question, you should be able to just delete the whole code and rewrite it again. And if you were not able to solve a question, then there was something which you didn't know before, which you came to know after you read the editorial for the question. So just try to figure out what that specific thing was which you were lacking. And if you just had known that thing, you would have been able to solve the question. So try to figure it out, and maybe you won't get 6 wrong answer on test 16. To be honest, I think I am also autodidact. Cool. Because in my college, I Nev B. Shit, I don't know. Nev B. My English is not that good. Understand? I never understand what professor taught. I studied myself on library and passed. Yes. Yeah, colleges are bad. Colleges are bad. Just get out of there. Don't go to colleges. They are bad. Have confidence in yourself that you can make yourself good enough and get a job on your own. That is nice. And enough yapping, I guess. Now back to the question. This question is just 3 lines, and that is scary. Let's see. Okay. Autodidact. You are given an array A1 to AN with n numbers. In one operation, you can choose 2 elements I, J, and decrease each of them by 1. You need to check whether it is possible to make all the elements equal to 0 or not. Okay. Differences. Hmm. I need to have pairs. I think the sum should be even. If the sum is even, then answer should be okay. This is even, this is even. 5 plus, yes, 1 plus 3 is 4. That is even. 5 is not even, so we won't be able to do this. I think the sum, no, 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 no. Not always, not always. First, yes, that is one thing that has to be there. Sum has to be even. No, nope, no, I'm lying. That is not the right thing. Difference has to, it has to depend on the difference. Okay, yes. Okay, yes. Shit, yes. Prefix. I think if I can, I will first of all take the whole thing and shit, again. No, that is wrong. Not even prefix. If there are elements which are equal, that is amazing. And for the numbers that are non-equal, as you could say it, I need to divide these numbers into two groups, into two sets where the sum is same. Shit. Okay, this is dynamic programming, and I can show you exactly where I have done this question before. In here in the dynamic programming section, two sets. This is the same question. Two sets, essentially the same question. Your task is to count the number of ways for numbers 1 to n can be divided into two sets of equal sum. That is what I have to do. Two sets, right? I think that is what I have to do. Instead of 1 to n, the numbers that I have are these. I can think of these as coins given to me, coin change. And using dynamic programming, can I get to a sum? First of all, the sum has to be even. First of all, the sum has to be even, and second of all, I should be able to reach half of that even sum using some manner, using some combination of these numbers. Here the half is 3, and I can get to a sum of 3 using 1 and 2. Here half is not valid because the sum is odd. The sum is 21. 21 is odd. So that is bad. So no, no. And I think that would be okay. That would be correct. How many elements do we have at maximum? 10 power 15. That is okay, but if that is some can be very big, some can be very big, and we don't want to do this. Is there some other simpler way? I think there is no other simpler way to do this other than dynamic programming. I need to be able to find, is there a selection, a subset of these elements which have been given to me, which has a sum that is half the total sum. Only then can I get something valid. And also there is like the fact that no, no, that is cool. That is cool. I need to be able to get to a sum that is half this current sum, and that would be nice. Again, we do not have multiple test cases. We have a single test case. Int n, taken n, vector of integers a, size is n, for int I equals 0, I less than n, I plus plus, take the current number in ai, and we will also have a long sum which is initially equal to 0 and sum plus equals ai, and then we'll see if ai is 1. If ai like is odd, then see out no, no, with a capital O, and yes. Else, if that is not the case, then we need to find half, and sm, we need to find half of sm with this right shift sm by 1 amount. Now we need to know, can we get to a sum of sm, what the current value of sm is? Can we get to that sum using these provided points. Yes, that is what you need to know. Half, 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 half. Yep, half. But the thing is, SM can be very big. So what do I need in my state of dynamic programming? SM can be very big, right? It can literally be very big. I'm also trying to learn competitive programming. I can only solve 800 rated questions. Yes, 3 months ago, I was having difficulty even solving 800 level questions, and you don't know how I get better at problem solving. Just keep solving problems. How much time should I be given to a question? Because currently I'm trying to solve a question from yesterday, but not being able to solve that. Now I think that should see solution or give me some more time. You can generally tell, I think, if you should give enough time, but yes, after a point, it is just better to look at the solution because it might be using something that you do not know about. And keep in mind that you do not have to discover every algorithm that there is out there just after reading the question. So you can look at the solution. It is fine. I'm trying to improve my English, I would say. And now this thing is a bit difficult because here the state was 500, but here the state is not 500. It is a lot. So yes, we have to do something else other than this dynamic programming approach. I think greedy will also work here. I think greedy will also work here. First of all, the sum has to be odd, has to be even, that is like given. And then if I have a number and the next number is the same as the last one, then okay, I can sort the given list. And if the first number is equal to the last number, okay, that is okay. Okay. When all the common occurrences are gone, then we do our actual thing. That is nice. SM has to be first of all even, and yes, the total sum has to be even because we are always reducing the total sum by 2. And now vector int unique reserve size n. Reserve size n, and then for int l equals 0 and r equals 0, r lower than n, and l equals r, we are going to iterate and find the subsequences while the left thing is equal to the right thing. And before that, we will sort a dot begin and a dot end. Sort a dot begin and a dot end while left is equal to r. We will do r plus plus. After this, R is pointing to something that is not equal to AL. R is smaller than N. That is another condition. And now, if R minus L is greater than 1, we have more than one copy. No, whatever it is. Yes. If R minus L is odd, if R minus L is odd, only then we will add it to unique dot push back AL. Now we only have the unique numbers and also that is also sorted. Now we will start iterating from the left and we will have two pointers and L is 0 and R also equals R equals N. Unique dot size, that is size of R, unique dot size -1. There is the R pointer and not for while L is lower than R. While L is lower than R, if we will keep this take the smallest element and take the biggest element till now which hasn't been decreased and make this left element equal to 0 and also reduce from the right element the biggest element whatever the left element is. Now if a unique R is greater than unique L, greater than or equal to, does not matter, what we will do is unique L equals 0 and before that unique R minus unique L and make this 0 and else unique R is greater and also L plus plus. Go to the next smallest element. And if that is not the case, then first of all, unique L minus equals unique R and then R minus minus and unique R before this, unique R equals 0. And after this, we should shit, I've messed up. What if we have something like 112? This will fail. This will fail if we have something like 112. So this is wrong. Yep, this is wrong. If we just have something like 112, this will fail. The dynamic programming approach seems the best. Where we are looking for half. Is it possible to get to half this total sum? The total sum here is 6 and we can get to half, which is 3 by choosing 1 and 2. But the only problem is this thing. The half can be very big because AI is very big. And at max we will have 10 power 5 numbers to choose from, which is a lot of numbers. So greedy algorithm is not going to work. We need something dynamic. I think if we have this in a sorted manner, whenever I could say dp of I would tell me, is it possible to have uh, is the condition true for all the elements starting from the first one till the ith element where I is 0 indexed, and the ith element is also included in dp of I. And if I have that, but whenever I see the next element, how do I choose which selection of elements I need from the previous array, from starting to the ith element, which selection of numbers do I go with? And even if I am able to figure out, okay, what I need is whenever I add a new number to my list, its sum has to be equal to the new number. Yes, its sum has to be equal to the new number. And in, but the thing is, yes, I need to have those numbers chosen from I the DP table would only be beneficial if I have chosen those numbers from the end of the table where I have been till this point, and that is not going to be the case always, because if we have something like this and I have dp of 0 equals to 0, 0 means false and 1 means true, here it will also be 0, here it will be 0 again, and here it will be 0 again, and shit, but here it will be true, and yes, here it will be true. The answer will be true because I can pair these twos with this 4 and this, wait, no, yeah, these twos will be paired up with each other, and this 1 and 3 would make up the sum of 4. Wait, here I am always taking a big element and trying to make its sum from other two elements, but also the answer for those other two elements depends. I like here 2 and 2 also add up to make 4, but I do not choose them because if I do choose 2 and 2 to be paired up with 4, it is going to be wrong. So that DP approach in which we are dividing all of the numbers into two subsets where the sum of one subset equals the sum on the other subset, but the condition, the time complexity is bad if we do go with this approach. Two sets, the time complexity is very bad because a power n is very big, so let's analyze the time complexity for it, because at this point to me it seems like this two sets approach is the only viable approach, because we cannot go with greedy. I cannot think of any greedy algorithm that would work here. Nope, greedy just seems wrong. It might seem right intuitively, but no, it is failing because I cannot always pair up one with any number x with the same number, because it might be needed somewhere else, and I also cannot always pair up the biggest number with the smallest number. Wait, I can actually. I cannot actually, because if I here pair up 2 with these two ones, and this 2 is just left alone. So both of those greedy approaches fail. So we need some dynamic approach, and this seems to me the only one, because if we go like element by element from left to right, that also seems to be failing in some ways. For an example, like this till this fourth element, it was not, this array was not following the conditions, and on the fourth element it started to like be true, but how, right? How? That is wrong. Maybe I can keep some extra state here. Okay, shit. Okay, here when I'm at 1, answer is 0, but also let's let's be better than this. Okay, we have numbers 1, 2, 2, 3, and 4, and we can say we have two things. First is a DP vector, and let's say another is a SM sum vector. I think we don't even need the DP vector, but let's, okay, I guess we don't even need the DP vector. And here for the first element, we will initialize it to 0, to 1, which is equal to the first element. That is how much sum is left over and is not filled. So the answer for the first element is always 0, is always no. Then we get number 2, and we can say if we pair up this leftover 1 with this new 2, then we can subtract 1 from both the sides and we will get 1 as leftover again. And same for this 2, we will get 1 as leftover again. And now here we will get 2 as leftover, and then we will get 2 for leftover here if we pair up that with 4. So that is also bad. Nope, that is also wrong. Yep, that is wrong. So we need some better approach. Two sums seems to be the best, and the thing is here with two sets, the time complexity is too high, because here we have n equals 500, but here we have n equals 10 power 5. That is not very good. 10 power 5 is a bit too much. Can I divide these elements into two halves which have the same sum? If I can, it would be very good. So I need to reach some sum. I need to reach some x, some like SOME, sum SUM, sum, which is equal to x. And I have a vector A. I need to choose some elements from this A, from whatever the elements are, total elements. I need to choose some elements from A, so that these green elements, when I add their sum, they should be equal to A. They should be equal to x, and subsequent, since x is half of the total sum, these white elements would also add up to be equal to x, and I can pair them up and I will get 0 as the final answer. dp dp. But the problem is x can be very big, and what can be x can be, since a at maximum can be 10 power 9, and in total we can have 10 power 5 elements in a, therefore x can be 10 power 14 by 2, which is like 10 power 14. And yes, we do not want to have something like this. This is very big. And just the time complexity is going to be very big because here each number has two choices, two subproblems. In one subproblem, we are choosing the current number, and in another subproblem, we are not choosing the current number. So for every element, there are two subproblems which need to be solved. So it is the total number of subproblems is 2n. It is the total number of subproblems just 2n. Hmm. I'm just trying to think of a way. Yes, the total number of sums possible is going to be very big. The total number of possible sums is going to be very big. Yes. Yep. Yep. The total number of possible sums is going to be very big. And that is wrong. Yes. Like on average, there are if there are n elements, then there are going to be 2 power n possible sums about approx. And that is a lot. If we have n 10 power 5, that is a lot of sums. Literally a lot. So this is not the right way. There has to be some other method. And I think there has to be some numeric approach to this. We don't want to know if what the exact pairs are. All we need to know is is it possible to make these all of them equal to 0 or not. Yes, I have number 1, then 1, then 2, and then 2. And let's say I have a bar right here, and this bar is moving down, and yes, if there are even number of elements, then whatever the smallest element is, I can subtract it and we are happy. Then next smallest, we can subtract that from all of the elements and we are happy. Wait, if there are even number of elements and if the total sum is even, then yes, it is not always possible. What if we have two elements which look like something like this? That is bad. Okay. So what we can do instead is we can simulate this line going up. I think if we have elements like this, if we have Yes, okay. If we have elements in any way, any if there are even elements, right? If there are even, no, I think all I need to know is the distances, the differences. Somehow that is going to help. But what if what in this case 1 1 and 2, here the difference between these two is 0 and the distance between these two is 2, so is 1. The distance is not the thing. Ah, I'm unable to think of a solution here. The maximum element that this element can reduce is 1. The maximum element that this can reduce is, and this is 1, so this can be reduced using this element. That is good. And also we have the option of not reducing, and the maximum capacity would be 2. Then when we are here, we can say the options are 0. So dp is possible at this point. So we have a dp vector and also another vector. A dp vector and some vector, you could say. dp, it is false here, and the maximum sum this could have is 1. And here dp is possible because here this current element is equal to sum, and the possible sums are, possible sum is 2. We can say that the possible sum is also 0 by the fact that dp is 1 here, so it is possible to make a sum of 0 here. And then when we see 2, we see what is the maximum possible thing, not maximum but the exact thing we can get is 2 here, and yes, is 2, which is true. So dp1 and then the sum is 0. And then we, let's say, saw 3. Now dp is false and sum is 3. Then let's say we saw 4. Is it possible? No, sum is 7. What if we had one other 1? Then this thing would have been true. And let's see what our table would look like. 1 1 1 2 3 4. We will have two tables, a dp table and a sum table. Here sum is 1, dp is 0, sum is 1. here dp is true, some possible maximum is 2. We will just add to the last one, and here dp is 0 and the sum is 3. What do we write? 3 or 2? 3 or 1? Choice is up to us. 3 or 1. No, this is not going to work. This is wrong. Okay, I will think about this for a little bit more and then we can look at the editorial. But this just feels, this should be very simple because the question is just 3 lines and it makes total sense. And it just feels like there is some little thing that I'm not unable to think about. And if I could just figure that out, I will be able to solve this question. Yes, so some condition has to be true, only then we output yes, otherwise we output no. So what is that specific condition? Like if that condition is true, then it is always possible to do this thing to make every element equal to 0. And if that condition is false, then we can never make these elements equal to 0. Yep. Here the answer is true for the whole vector if I choose 4 with 3 and 1. And if I were to represent these using bars, I have 3 bars of height 1 and 1 bar of height 2, not to scale, 1 bar of height 3 and 1 bar of height 4. And since this is in total, I have 1, 2, 3, 4, 5, 6. That is even number of bars. I can, let's say, I can pair these up, these and these up, and let's say I reduce the amount that is smallest and common. So now we have a bar of height 1, a bar of height 2 and a bar of height 3, and then I take the next smallest and I subtract that. Now we have a bar of height 1, but now it is odd. The number of elements is odd and I cannot pair them up completely. So what I will do is, since I cannot create a line like this, what I will do is keep the smallest one to myself, like separately, bar of size 1 separately, and like do not think about this for the moment, and we can create a line here. Okay, and here, since the height of this bar is 2, I will subtract 2 from 3. I will get 1. Now this leftover bar, is it equal to this bar? Yes. So answer is yes. And we can, I think, actually simulate this thing. Not specifically going through all the elements at once would be time complexity n square, but I think we can do this in n time. We will sort the whole thing first of all, and then we can take a counter equal to some number, and yes, But and also we will have some. No, we won't have anything. Oh shit. Okay. Yes, this is right, but now all we have to do is reduce the time complexities of this sweeping algorithm or whatever it is. Yo, 300 on lead code. That is pretty nice. That is pretty cool. And now you can start giving contests. I think contests are amazing, like pretty amazing. And right now we are trying to do this question. This question seems very simple, like it is just 3 lines of question, but I think I have it done. All I have to figure out is the implementation of this thing. Yep, questions. Contests. Today is a contest. Like yes, laptop is going to die. Today is a contest. In like a few hours, in 4 hours from now, exactly. Uh, to be exact, 3 hours and 59 minutes. I think. Oh shit, this is not charging. Wait a minute, let me fix that. Yep. And contests are very fun and very stressful. Yep. In code forces, there is a contest and 3 hours and 58 minutes from now. I mean, you can give it. It is going to be very fun. I'm not giving today's contest because it is like at the wrong time. It is 5 in the evening and I might have to get up. Um, and the contest is for 3 hours. I might not be free in that interval. And now I'm thinking about how I can implement this. I go with the tower with the highest, with the most weight. Yes, shit. I go with the tower with the highest weight. Okay. I have 1, 1, 1, 2, 3, 4. I take 4 as my counter and I go to the next smallest element. And if this is smaller than this, seems like it, I can take 1 as extra spare. Like I will have a counter of how much I can reduce from the next thing. Is how much I can reduce. Initially, it will be equal to 4, and I will start iterating from the second last element. And here I will see that this thing is smaller than my counter. So I reduce from this, whatever it is, and my counter will become 1. And I will go to the next element and I will see, is my counter smaller than this? Yes, here my counter is smaller. So I will subtract from this element whatever my counter's value is and put my counter equal to that like subtracted product, and I will have 1. Then I will go to the next element and I will see this number is not greater than my counter. So I will just subtract from this thing my counter and update my counter's value, which will become 0. Then I will see that this thing is greater than my counter, and I will reduce from 1, whatever my counter's value is, and put that equal to my counter, which is 1. And then I will go to the next element and put my count, subtract from my counter this value, and my counter will become 0. Shit, I guess now I am able to get it since you came. I would give it a try. Yes, that is cool. All the best. But yes, today's contest cannot be like unrated. If you are participating in today's contest, your rating will go up and down, and that is something. But yes, tomorrow I will give this contest virtually. That is, I will participate in today's contest tomorrow on stream as if I was actually giving the contest, and that would be fun. It would be my first virtual contest, and that would be fun. And shit, I think I get this one now. And does not matter. I can start from the left or from the right. Shit, how was I this stupid? Should I guess I removed the wrong question. Ah, wait, it is this question. B0 array. Yes, it is the same question. What are the things? N and then the array. Cool. CNN and CNN what vector int a size n for int reference x in a c in x and then counter equals a 0. But before that, let's like wait, we don't even need to sort a. We can just bulldozer. Can we? Yes, we can. And C out depending on a C. If C equals 0, if not C, then yes. Otherwise, no. With a new line, as someone would say. And here, if AI is smaller than C, if AI smaller than or equal to C, we will do C from C, we will minus AI. AI. Else, if that is not the case, then C equals AI minus C. If AI is bigger, then C equals AI minus C. Yes. And is that literally it? Shit. And I'm trying to think of a counter example where this would fail. And before I do that, let me go to the washroom. I gotta solve some stuff. Then see, yeah. And by the way, how is the question level? This one is 1500, but this seems simple now. And also, you said that you were doing some bitmask DP. There is this question on CACS on bitmask DP. Like, I do not know how to do bitmask DP questions. But this one, elevator rides, and this one is apparently has to be solved using bitmask DP. I'm learning about bitmask DP also. I'll be able to do this in a few days. But yeah, I thought this might be interesting to you. This has to be solved using bitmask DP as I have heard. And okay, I'll go to the washroom later. First, I will submit. Let's see. In queue, running, hopefully, hope, hope. Okay, it is back in queue. It was running. Yeah, it messed up. It messed up. Here, expected yes, you would be able to do this one somehow. Answer is yes for this one. How? I'm using a greedy approach, but how can okay, first let me go to the washroom. I'll be right back. Cool. I'll try. Yep. All right. See you too. me back, me completely back. And how can anyone do this one? Like, is the number of zeros here 3? Shit, I messed up. 1, 2, 3, 1, 2, 3, and then 1, 2, 3. 9 zeros. 1, 2, 3, 3, 1, 2, 3, 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3, 9 zeros, and then 1, 2, 3, 2, 3, 1, 2, 3, 9 zeros, and then 9 zeros here. 1, 2, 3. Uh, How can someone do something like this? Why would it be yes, even from a human perspective? Shit. Yes. This makes sense. This makes sense. Yes. If I have three things of size x, x, and x, I can say that I took half from this and half from this and reduced this one using half from this and half from this. This became x by 2. This became x by 2 and this became 0 because x. And then like I can just make these two 0 by pairing them up with each other. So I can reduce something of size 3 also. There are nuances to this. I can reduce something of size 3 to 0 using this. If they are same, if they are equal, only then I can do this. Mhm. Okay, and let's say, so this is the only case I think in which my algorithm fails. And if we have count of all the elements, uh, x, 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 and then y, y, and y is, let's say, bigger than x, then if I'm using a greedy algorithm, these two will become 0. Then my counter would become equal to c, and at this point, I will reduce from y, x, x, yes, and my counter would be equal to y minus x, and then I reduce from y some small number y minus x, so y minus x plus x. Uh, what is left over is x somehow. X is the amount that is left over. That is crazy. I had x as my counter at this point, and from this number I reduced this thing y minus x. Yes, then my counter became equal to this thing, and then my counter became equal to y minus x. Since this thing is obviously going to be bigger than y minus x, let's say it is bigger than y minus x, then the counter would be equal to just x, and then I will subtract this from y, and finally my counter would be equal to y minus x, and that is, I cannot even look for something as x in there. Maybe, yep. What if I have 1 1 1 1 4? I take my counter equal to 1, go to the next element, it becomes 0, and next 0, and 4, and boom, fail. So my algorithm doesn't work when I have multiple occurrences of the same number. Or if I do start from the end, then also it would fail if I have multiple occurrences of the same number at the end. So multiple occurrences is the factor which is messing things up. When I have multiple occurrences, then my counter possibly, if the number of occurrences is even or odd, it does not matter. If the number of occurrences is exactly equal to 1, then my counter is strictly equal to that number. But if the number of occurrences is higher than that, then if the number of occurrences is, let's say, nx, the number of times x occurs, if that is even, then my counter can range from 0 to 2x to 4x till boom, any number of n by 2x or nx, n by 2x, nx, nx, yes, nx, yes. Nx can be the maximum value for the counter. And if n is odd, then I can have multiple values. Shit. And not just this shit here, I can have x, I can have x, 2x, 3x, 4x. Shit, I can have total precision with a difference of x. It is just the lower bound that is changing. If nx equals 0, then I will have counter exactly equal to x. Otherwise, I can have any precision from x to from 0 to x to 2x to 3x to total nx amount of x's. Shit, the coin change approach, which I was thinking about earlier, would fail on an example like this. If x here is even, only then it is possible, and it would fail here. Yes, it would fail here. It would fail here. Yes, okay. And so it is like, I guess, time to look at the editorial, and it will be fine. I can look at the editorial now. It is fine. And shit, I have only done one question, but okay, that is okay. Can I look at the editorial? Yo, shit, my bad, my bad. The big fan of your videos. Thank you. Reply, yes, I have some doubt, bro. Yes. Uh, you have some doubt? Yes. I am open to that. Anna, Anna de Armas. We can look at the editorial now. For this zero array, that is the question in question. Yes, yeah, the delay is 8 to 9 seconds. So it will take you 8 to 9 seconds to see that I'm looking at the chat. Okay, you want to start competitive programming, then also there is a Discord in the link in the description, Discord link. You can join that. There are resources there. And also, since you want to start with competitive programming, you need some place to read theory from, which you can do from here, Competitive Programmers Handbook. This is a very nice book for like anyone. So you can use this for theory and some extra YouTube videos. And for questions, you can go to this website, TLE Eliminators. So for theory, you have this book. And for questions, you can go to this website, start solving question from 800 rating till like wherever you go. And whenever you see a topic that you do not understand, you can go to the book and read about it. And you can find this book easily if you just search CP Handbook. The first link from CACS, and that is bad. That is shit. That is very cursed. Why is this in dark mode? No. Wait, shit, I can have PDFs in dark mode. That is crazy. That is crazy. I do not like this thing on the right, which is in dark mode, but PDFs in dark mode is amazing. Shit. This thing is preserved. The color for this thing is preserved. That is nice. This looks good. PDFs in dark mode. And back to the editorial. Let's see. How long have you been learning this? Specifically competitive programming 87 streams. This is my 87th stream today, and I became serious about competitive programming at the start of August. It is September now, about 2 months, and you can also reach the same level in 2 months, I would say. But yeah, I started streaming, I guess, at the start of July, so 3 months, technically speaking. Yeah, 3 months. In 3 months, you will be like this good, and this is not very good. I've been trying to solve this question for 1 hour, but I've been unable to. Ah, there are two things needed to be possible to make all of the elements zero. The total sum must be even. That is the first thing that I said, like among the first things that I said just after reading the question, and second, the biggest element must be less or equal to the sum of all the other elements. The biggest element have to be less than, the biggest element has to be less than or equal to the sum of all the other elements. Is it necessary to take the eliminators course? No, it is not necessary. If you have something else which you can do, which is like better, or like anything which if you have anything else, you can do that. Don't have to go through the TLE course. It is not a course, it is just a list of questions. And I don't know how I would be looking for questions when I don't even know what competitive programming is. So I just went on with this sheet of questions. This is not a course, this is just a list of questions. and this seems pretty nice to me. And this fact is crazy. If the total sum has to be even, that is condition number one. And second condition is they are saying that the largest number has to be either smaller than or equal to the sum. Oh, I went to the code section. Oh, you went to the code section. That is fine. You can just solve these questions for free. That is nice. Yeah. Do not buy things. Buying courses does not feel good. Shit, I think we can use induction to prove this. I think we can use induction to prove this. Okay, let's set up the base case. What we want to prove, induction hypothesis is this. First of all, there are like two conditions. Total sum is even. First condition. Second condition, largest element is smaller than or largest element is not greater than the sum, than the total total sum term. If these two conditions are true, then the inductive hypothesis is that yes, we can pair these elements up in a way such that their sum is equal to 0, right? And let's use induction to prove this. So these are the two conditions, and let's first of all set up the base case. Base case, in the base case, we just have two elements when n equals 2, right? And when n equals 2, there are only a few conditions possible. Wait, I think I read the editorial wrong. The biggest element has to be less than or equal to the sum of all the other, to sum of all the other elements. Okay, not total sum, but sum of all the other elements. That makes more sense. Greater than is not greater than the sum of remaining elements. These are the conditions, and our inductive hypothesis is that if these conditions are true, then our answer is yes. And our base case is when n equals 2, and there are only few possibilities. Since we have only two elements and we have sorted them in sorting order, in like ascending order, then there is this possibility that the second element is equal to the first element and the second element is greater than the first element. These are the only possibilities because we have sorted our array. So you could see if the first element was greater than the last element, then since we are sorting our vector, we would have this smaller element as the first and the bigger element will go to the right, and this would be same as this condition. So there are only these two possibilities. And is it bad to use AI when solving these questions? If it depends, you can use the way that I use AI is I have a very specific question that I want to ask, and my goal is not to solve the question, but my goal is to understand that concept. And I use AI as a teacher or as a friend who knows more than me, and I can talk to just AI and get my hypothesis right. For example, if there is some concept like loop invariance, then I will type to AI or tell AI what I think what the definition of loop invariance is or what loop invariance is. I will tell the AI what I think it is, and then AI will correct my view and yeah, to just correct my views and clear my doubts. That is the only reason, the only thing that I use AI for, and that is nice. Not to solve questions, but to clear my doubts, and AI is very good for that. Yes, in base case, we have two conditions, two cases, and in this case, can we use induction? I think we can use induction. In this case, this is true. Let's look at this case first. Is the total sum even? I think the total sum will always be even in this case because both the elements are same. So total sum is going to be even. So first condition is true here, and the second condition is largest sum not greater than the sum of the remaining elements. So largest number is this, and the sum of the remaining elements is this, and they are equal. So the largest element is not greater than the sum of the remaining elements. So second condition is true. Our inductive hypothesis says that the answer here should be true. And we, as humans, we can see that the answer here would be true because we can just keep pairing up these two elements and keep reducing one from each, and they will both hit 0 at the same point because they have the same values. So for base condition 2, in this case, answer is yes. So this base condition is correct. Now let's look at this base condition. Here is the total sum even? It might be, it might not be. And the second condition, so the first condition we are not sure about, might be correct, might not be correct. And the second condition is always false because here the greatest element is this, which is larger than the smaller element. And when we have this as the largest element, the sum of the smaller elements, the rest of the elements, is smaller than the largest element. So second condition is always false. So these conditions are false, and our inductive hypothesis says that if these conditions are false or any one of these is false, then the answer should be false. And we as humans, we can see that the answer would be false because these are the only elements that we can pair up, and when we pair them up, they will not hit 0 at the same time because the second element is higher than the first element. So when the first element becomes 0, the second element would become a2 minus a1 if a1 is the first element and a2 is the second element. This would be the value of the second element when the first element hits 0. So our base condition is cool. We are happy with our base condition. Very good. Good luck. Yep. Thanks. And now inductive step. The inductive step says we have to see if for n our inductive hypothesis says yes, and then we add a new element. Is it still going to be true? Since we are saying, I think induction is not the right proof for this. Yes, induction is not the right proof. Let's try to apply induction here. If we have, nah, induction is not the right proof. No, I don't know how we would go about proving this statement. And this is one of the things. Now I have a doubt, and I will do some research, and then I can go to ChatGPT to ask how I can prove this thing. And for now, let's just solve this, and I will look for the proof of string because that can be very boring. Int n, cnn, and long sm sum initially 0 and int c for int I equals 0, I less than n, I plus plus, taken the number into C and Sm plus equal. Now, if Sm is even and the largest element, shit, I will have to sort the thing or not. Mx equals 0, Mx equals maximum of Mx and then the second condition, which is Sm minus the total sum minus the maximum element. This thing has to be greater than or equal to the maximum element. If both of these conditions are true, then see out yes, else see out no. Yep, S funktioniert. Yeah, I think this is going to be nice because I will learn a new way to prove something. I only know about induction and I do not think induction is going to work here. Or even if we can use induction here, it is going to be a bit more complicated than the normal version of induction that I know about. Accepted. That is okay. 1 hour and 20 minutes for that. 1 hour and 20 minutes. That is nice. Nice because this is a learning step. We learn in errors, and this is an error. So that is nice. Hmm. Okay. Questions review. I will review this question of the stream. That is nice. Do I want to move on to the next question? No, no, no. I would like to first of all revise what I have done till this point. Okay. We have done two questions. This one, count subrectangles, and this one was easy. Not easy, but this one was intuitive. And it took me time. I guess it took 38 minutes because I was speaking a lot. And then this one, but yeah, this one was easily doable because I knew what I needed and that was good. But in this one, I didn't know what I needed. So yeah, I will have to do some research on this one, on this question. First of all, okay, so there are two things that I will have to get into for this question. One is I was able to figure this thing out immediately, and that is good. But I was unable to figure this thing out. And I think it is so. First of all, there is this thing, like this condition that has to be true. So there are two things here. First is how would I have been able to figure out this condition has to hold? And then second, how can I prove that this condition must be true for all the cases? So there are two things I will have to learn, and that is okay. Yes. Now I can move on to the next question. Edgy trees, whatever that means. Shit. There are literal trees in this question. In a while, when I have done all of these 1500 rated questions, I will go heavy on graphs like I did with dynamic programming. That would be nice. That would be really nice. There is some update in OBS. Remind me later. And 2 hours and 20 minutes. I will stream for at least 3 hours and 30 minutes. So I guess two more questions. Let's start. Let's start. Let's start. You are given a tree, a connected, undirected graph, a tree without cycles of n vertices and minus one edges of the tree. edges of the tree is colored in either red or black. Okay. You are also given an integer k. Consider sequence of k vertices. Let's call a sequence a1 to ak. Good. If it satisfies the following condition, we will walk a path, possibly visiting same edge vertex multiple times on the tree, starting from one end and ending at k end. Okay. Start a1, go to a2 using the shortest path between a1 and a2, which would be the simple path. And similarly, go to a3 from a2 and similarly so on until you travel the path from ak minus 1 to ak. If you walked at least one black edge during this process, then the sequence is good. If you walked over at least one black edge, then the sequence is good. Okay, okay. Of k vertices. You are also given an integer k. Consider sequence of k vertices good. So consider in the tree in picture if k equals this, then how many sequences are good? 7, 3, 6, 2, 7, 3, 6, 5. Okay, so this thing has to be there. Yes, this shit, they are going to be. It's 5, 3, 5. 5, 3, 5. Shit, I can choose any vertex possible. Okay, I need to identify all the black vertices. What even is the question? There are n power k subsequences of vertices. Yes, count how many of them are good. Since this number can be quite large, give the modulus. This is doable. I just need to find out all the black edges and see how many nodes are like to the right of this black edge and how many nodes are to the left of this black edge. That would be very doable. So yes, that is the only thing that I need to figure out, and then it would be a mathematical question more than a graph question, and graph is mathematical, my bad. And now I'm thinking about how I can go about figuring this out. If k equals 1, then answer is 0. Then answer is always 0. 6, all of them are, I guess 0 means red. The first line contains n and k. K can be 100 at max. Okay. And because I do not want to use DFS on each node that is connected to a black edge because it will be very expensive. Yes, it can be very expensive. Each of the next n minus 1 lines contains three integers u, ui, vi, and xi. Yes, ui, vi denote the endpoints, and 0 denotes red edge, 1 denotes black edge. For every black edge, I need to find, like, for example, in this question, I have two black edges, right? Number one, edge number two. This edge, number one edge. Let's say that this edge is the number one black edge. On one side, it has two nodes, and on the other side, should I do not have to apply the DFS algorithm on the whole thing. I just need to apply it on one side, and the answer would be total number minus this thing, the thing on the other side. Let's do this for this. Yeah. Let's do this for this. Yes. For this graph, here our graph looks like this. 1, 2, 3, and 4. And we have 1 is connected to 2, 2 is connected to 3, and 3 is connected to 4. And all of these are black. Let's say for this first black, this is the first black edge, second black edge, and third black edge. Second black edge and third black edge. For this first black edge on the left, we have 1 vertex in total, and on the right, we have 3. 1, 2, 3. The size of this subtree is 3. And for the second one, which is this, it has on the left, on one side, it has 2 vertices, and on the other, it has 2. So 2, 2. And for 3, we have the division as 3, 1. Now, for what is the value of k? K is equal to 4 here. So, first of all, before anything else, I need to make sure that this edge is involved. And it I'm going to repeat parts. My bad. I should not have banged the table like Magnus Carlsen. Uh, I'm going to repeat the answer. Yeah, multiple counting. Yes, answers are going to be repeated. Yes. Uh, yeah, because I can say, since I do want to include, can I reduce this to more fundamental things like thinking about this in terms of graphs could be a could be avoided, I think, using some other mathematical model. Mm, yes. I think topological sort is one thing. Ah, shit. Yes, we are going to repeat answers if we were you going to use that thing. Yes. Yes, topological sort. No. Yes. Okay. No, not okay. I think a version of TFS is going to be fabulous. Some variation of the DFS algorithm. I think I can use it here. DFS, DFS, DFS. Okay, let me try to implement it, and I'm thinking of a way to do this. And let me first try to implement it, and then I will try to explain what I am doing. We don't have to do this. Int n, and not just n, there is also k. K is at max 100. That is okay. Take in n and k and bonds in m equals 1e9 plus 7. After taking this, what is the data structure in which I'm going to store this? It is going to be an integer of pairs. Yes, pairs, and we can call this edj as in adjacency list. They are going to be n vectors, n plus 1, so that I don't have to make them zero index, all the nodes. I can work with them as they are, or I can make them zero indexed. That is fine. That is not even the concern. And the spelling for vector is wrong. Vector. And internally, vector, initialize a vector of pair of integers, like that. Size 0 and pair of integers, like that. Cool. Yeah, that is nice. Then for int I equals 0, I less than n, I plus plus, I less than n minus 1. And we will have three values, left, right, and C as in color. We'll take all three of them, left, right, and color. Left, right, and color. That seems like a political debate. And then we will do adj bracket left dot push back a pair which says R and the color is C. Let me also write this somewhere. First in the pair is the vertex and the vertex. I messed up. Vertex, but node. No, vertex seems more professional, looks more professional if the spelling is right. Vertex, and the second is the color, and adjacency right before that L minus minus to make it zero index, and R minus minus, push back left and color. Okay, now the data structure is filled. Now we need to apply some DFS, a version of DFS. And this is going to be very amazing. This is going to be very cool. Shit. Yes, this is going to be very cool. A very cool version of DFS. But there are just a lot of factors. What are the essential information I need? How many black nodes have I seen since I started my journey from till this route? So the thing is this: if my graph looks like anything, like whatever, right? It is a tree. Whatever the path is, I know where I am currently in my DFS algorithm. I know where I am currently, and I know where I started. And on the way, I must have seen some black nodes, red nodes, and black edges, red edges, and black edges. I am calculating what the answer would be for this simple path, starting from my starting node till this node. What the answer is, if I just include this new node, it does not matter whatever the answer was till now, but let's say I have the answer for this whole thing. How would adding this new node affect my answer? It would depend on if this one is red or black. Let's say this edge is red, then all the black edges till this point can have this as one of the viable options. Yes, this is also using inclusion exclusion principle. Yes, seems to be just it just seems to be getting like more complicated. Ah, shit, yes, because this new edge can go anywhere in the subsequence that we are choosing. And the total length of the subsequence is k. This just seems so many things are going on right now. Okay, let's say k is also some value, and I have the answer for this whole thing. But no, do I need to know the answer for the whole thing till this point? I don't think so. I just need to know the length, the length till this point, which in this case is 3, not including this current one. Let's say it is also included. The length is 4. And then, nah, the time complexity is n square. No, no. The time complexity for this algorithm is n square because I thought I might have to go through. Yeah, the time complexity is n square. This is bad. No, this is the wrong algorithm. Not wrong, but not efficient. The time complexity would be n square because whenever I am adding a new node, I am looking at what the answer would be if we had this node, what the answer would be if we had this node, and yeah. Yes, and I think I need to know something like topological sort here. DFS with recursion or stack. But just think about that there can be in total n nodes. And whenever I add a new node to my simple path, whenever I call a DFS algorithm on a new node, then I would have to go through all the black nodes which have been till this point. Yes, that just seems unreasonable because there can be n minus one black edges in total. In total, there are n minus one edges, and in total, there can be n minus one. All of them could be black. The time complexity is not adding up. And I think I need to know something like topological sort so that I can, in this case, I can find an order. The order in which I am traversing through the graph has to be good. Like, no, 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 no. This is the basic approach that if this current node, okay, if I have a edge that is black, then I need to know the size of this sub graph, this node included, this size, this whole size. And let's say it is X, right? The number of total nodes in this right subgraph is X. And I need to know the same thing for this. And let's say it is Y. Then I'm looking for all the good paths of length k which include this node, which include this edge. And since I need to include this edge, so the first thing that I choose has to be some node from this side. I can begin by choosing some node from this side, or I could begin by choosing some node from this side. So let's say first we will choose some node from this side, and there are y nodes on this side. And then I choose some node from this side, and there are x nodes on this side. So in total, I can choose, I have y into x possibilities of choosing the first two nodes, right? And yes, after that, I can choose any node whatsoever, and I have k minus 2 choices left. And after this point, I can choose any of the n edges, any of the n nodes. So after this, the answer is going to be n power k minus 2. And this is when we begin choosing from y, but we could also begin from choosing from the right side, which is x. So the total answer would be 2 xy n power k minus 2. But there are like multiple problems with this approach. This is correct. This is wrong in one way and also inefficient in another. Dim, what is good path? Dim shortest, dime. There is only going to be one path because there are no loops and this is a tree. So the shortest path is going to be the only path that there is because there are no loops. And yes, there are multiple problems with this. First of all, multi-counting. I will be counting the same path multiple times, and that is bad. That is bad. Like if there is B1 a black edge, B2 a black edge, then when I'm applying this formula on B1 edge, then like if this is the answer for B1, this is the answer for B2, I can use inclusion exclusion to figure this part out. But to figure this part out, it is not going to be easy because I would like I have to know the orientation of these two edges. Like if I have x1 and y1, the sizes of subtrees for v1 and x2 and y2 as the size of subtrees for v2. I don't know if this b1, if this b2 is one of the y1 edges or one of the x1 edges. That is, but do I need to know that? Do I need to know that? Let's apply inclusion exclusion on two black edges. Okay, inclusion exclusion I can use. So okay, with inclusion exclusion there are this with this approach there are two problems. First of all, this inclusion exclusion, which we will see if we can fix it. We will see if we can fix that. But the second bigger problem is that this is not very efficient. How would I can apply one single DFS and find the answer for the whole thing. Okay, so inefficiency is fixed. All we need to know is this part, double counting. Can we fix the problem of double counting? And let's see. So what do we have? What do we have? What do we have? What do we have? We have uh we have two black edges, B1, HB1, shit, and B2. We have two black edges, and the size of subtree on one side of B1 is X1 and on the other side is Y1. And we also have, let's write Y1 as N minus X1, right? Cool. And for B2, these are X2 and N minus X2, right? And if we apply our formula, this formula, we will be able to figure out the size of this B1 set and also the size of this B2 set, and then we will add it, and then we will see if we can find out this intersection area and subtract it from the total answer. But it's still, even if we can fix the problem of inclusion exclusion, what if all the nodes are black? All the edges are black. If there are n edges, which can be at maximum 10 power 5, there can at maximum be black edges 10 power 5 minus 1, which is just 10 power 5. And we, to apply the inclusion exclusion principle, first we will go through and see, shit, this is bad, this is bad, nope, this cannot be done using inclusion exclusion, because we will have to see all the sets of size 1, then all the sets when we are considering two sets, combinations of two sets, then three sets, then four sets, then five sets. And this would make sense if you have read about inclusion exclusion, and we will have to go till we are considering the union of all the sets, which would be 10 power 5 minus 1 total sets, and that is that. The time complexity is back to very big. This is even worse than finding the path. Sort of, oh, this is not going to work. This is not going to work. Because this probably is using something that I do not know about. I've not worked a lot with graphs. I only know DFS and BFS. And like I have this tinkering. I have to read about graphs. Not right now. Shortest paths, tree algorithms, spanning trees, directed graphs, strong connectivity, tree queries, path and circuits, and flows and cuts. And that is it. Not edited. The graph algorithm section is very big. Page number 107 to 95. That is 88 pages. Mhm. Yes, this, yep. All the algorithms that I can think of are going to be very inefficient. And I, yes, I cannot think about an algorithm which would work here in a reasonable amount of time. I mean, inclusion exclusion is going to be very big. Yep. The time complexity for any method which uses inclusion exclusion, it is going to be very big. Radium trademark. How do you get TM like that in superscript? Can you teach Python? I'm not teaching anything. I'm not even teaching competitive programming. I'm just doing questions on my own with a camera on. But for Python, if you want to go to learn Python, you can do that. Who was that? That was like crazy shit. He is gone, whoever he was. Uh, you can do CS50 Python. You can take this course, which has 11 lessons and by Harvard, and this is pretty nice. This is a really nice course which you can take on Python completely for beginners. Lecture, there is even an introduction and then a lecture number 0. This is pretty cool. You can take this for Python. I can traverse 147. They are not even connected. I cannot traverse 147. It says in the question that you can choose any order of vertices and they're not connected directly, but they are connected indirectly because this is a tree. Every node is either connected directly or indirectly. And when you go from 1 to 4, since they are not connected directly, you take an indirect route like this, and this is valid. And then you can go to 7. Since 4 is not connected directly to 7, you will have to go to 2, then 6, then 3, then 7. Yep. So that is why this is very complicated, I think, because let's say since this is a black node and if k equals 2, then let's say you choose 5, then you choose 6, then the next node that you choose, I think it can also be 6 again. It can be 6 again. That is for the hell. And that would be a valid path. A path like here 5, 6, 6. This is valid. Yes. And I like this question. I like this question because this is seems to be using a couple of different things at the same time. I feel like I feel like this might be a graph question, first of all. That is what I feel like. And second of all, this might be using inclusion, exclusion at some level. That is what I feel like. And also dynamic programming at some level. I cannot see how this question is using these things, but I feel like this question is using these concepts somewhere. And graph in itself is not very easy. Inclusion exclusion can be very easy if the question is easy, and dynamic programming is like dynamic programming. It can be very hard. Right. And that is why I like this question. Or I might be just wrong, and there might be a very simple formula, exact closed form formula for this. Yeah, let's look at the editorial. It is going to be fun. Shit, this was by an Indian guy who is red at this point. He's from Pune, from Google, Pune, and he has been at this for some time, it seems. He's been at this since 2016. That is a long time. 2016. Yeah, that is crazy. And his rating is 2400. When did he give his last contest? In 2021. He hasn't given a single contest since 21. And he is a grandmaster. That is very cool. And he has solved a lot of questions, 3,200 problems. That is a lot of problems. And he he has solved a lot of problems. That is good. That is good. Some inspiration. And this anime character is, y- yeah, I think I know him from somewhere. Anyways, back to this. Wait, was he the only one who organized this contest? This was 7 years ago. I don't know. This is question number C. Shit. Okay, there was someone else also there. Thanks for the fast editorial. Nice. This was question C. Let's find the number of bad sequences. Shit. That is very stupid. I've just solved knapsack problem of dynamic programming. Knapsack is pretty good. I was very confused when I solved knapsack for the first time, but yeah, it is pretty good. And I still do not know how to solve optimized version of knapsack. For example, when we add coders, tasks, DP, it is opening, right? Hopefully. Shit. Yes. Here, this knapsack one is easy to solve. This is like the basic knapsack. But then knapsack 2, this one is difficult because here the value of W is 10 power 9 and you cannot iterate from 1 to 10 power 9 for every value. So I guess this uses some optimization. Yes, this does use some optimization. That is nice. Okay, so in the editorial, the first few words say, let's find the number of bad sequences. I can find out the total number of sequences, and I think I just need to find out the components. Shit, shit, this is, oh shit, I was so stupid. Shit. And I made the same mistake 2 days ago in a contest in question number 2. B of the contest. Yeah, shit. On Sunday or maybe it was on Monday. But shit. I- In both the questions here, I was starting from zero and I was trying to add new things to the answer and get to the answer. But it is much easier to start from all the possible configurations and remove the ones that we do not need. Shit. So here I think it is easy to identify all the components which do not have a black edge. Here we have two components. Let's go with this example. We will find out all the components which do not have a black edge. So the total number of answers we know. Since the size is going to be k, we can choose as the first node any node we want, any n nodes there are, we can choose as the first node. And what is k's value going to be? Minimum. K is going to be minimum equal to 2. Okay. And when we have made our selection for the first node, then there are n minus 1 possibilities for the second node. Why n minus 1? Because we cannot choose the same node again and again because we are not actually going anywhere. So First, we choose one node and then we choose some other node, which is not the first node. And then we have the possibility of choosing any node we want. And for this, we have n equals 4 and k also equals 4. So for total number of possible answers, which would be our answers, yes, the answer is going to be 4 into 3, then into 4 into 4, which is 4, 4, 16, 6, 64 into 3, 180, 192. That is wrong. 4 into 4 is 16, 16 into 4 is 64, 64 into 3 is 192, 64 into 3 is 192. But the total answer is higher than that. So I messed up somewhere. Total answer is 252. Ah, I messed up somewhere. Uh, for the first node, I have the possibility of choosing any node. Four possibilities there are. And then for the second, I cannot choose any of the fours that I did choose before because it would not be a valid path, which includes a, a black node. And then I can choose anything I want. Mhm. 64, 192. This is 192. How, why is the math not mathing? 252, 252, 256. Shit, makes sense. Okay, okay, okay. Uh, since n equals 4 and k equals 4, let's say a total number of answers is going to be not valid answers, but valid plus invalid. Total number of possibilities are going to be, first of all, we can choose any of the n possible nodes. Then for the second one, also we can choose any of the n possible nodes. Then for the third one, we can choose any of the n possible nodes. Then for the fourth one, we can again choose any of the n possible nodes. This is 256. And among these 256 possibilities, since there are four nodes, node 1, node 2, node 3, and 4, there are four paths and there is one path in which I just keep choosing one again and again. And in that path, I'm not going to any edge whatsoever, which is bad. And the same case for 2, there would be a path in which I just keep repeating going to 2, which again is bad. And then there could be a path when I keep going to 4 again and again, and for 3 again and again. So in total, there are n such paths, and they are of course not the answer. So I will reduce them, subtract them from this. Yes. So we will have 256 minus the number of nodes, which is 4, 252. And now in this graph, there is no red edge. And our task is to find a red edge, a component of the graph which has only red edges. And yep, we have to find a component of the graph which has only red edges. And when we find that, let's say for something like this, which is much better. In here we have k K I think is equal to 2. K equals 5. That is amazing. Okay. N equals 3 and K equals 5. So our initial answer is going to be 3 power 5. 3 power 5, which is, what is it? 81 into 3, 3 to 40. Yes, 243 minus n minus n, which is 3. So 240 answers which could be valid. And then there is, the graph looks like this. 1, 2, and 3. 1 and 2 are connected, 2 and 3 are connected. And among these, 2 and 3 is red, and yes, this is red. So there is only one component which has all red edges, and that is this one. And this one, all we need to figure out is the number of vertices in this red component, and it is 2. And how many paths of size 5 are there with this 2? They are going to be 2 power 5 minus 2. So that is just 32 minus 2, 30. And if we subtract 30 from this, we get 210. And I hope this is the correct answer. 210. It is the correct answer. 240. Yes, this is the correct answer. So all we have to do is figure this out. Okay, that is cool. We just have to figure out components which have all red edges. That is going to be nice. Okay. Twenty-nine plus 7. 4. And there is also going to be contest. Yes, there is a contest, but I won't be giving today's contest. Okay. Wait, it is 2 hours from now. Yes, 5. It is at 5 o'clock. And you see, contribution, that is pretty cool. Okay, let's do this. End, n, and k, c in n and k. And then for the vertices, I need to know their color and everything. And I will need some extra functions. Yes, I will be needing some extra functions, which one is for power, return an integer, power, takes in a, takes in b, and it takes in m. And then this function returns a raised to the power of b. And if b equals 0, then return 1. Otherwise, and answer equals raise a to the power of b by 2 and take modulus m just in case, and then answer multiplied by equal to. Let's have answer equal to long so that it can handle big things. Multiplied by answer, take modulus with m, and then if b was odd, then multiply answer with a and answer modulus with m, and then return answer. This is going to work. And what else do we need? We need this. Fine. This is fine. And now to store the data, we are going to use adjacency matrix, adjacency list representation, which will have, which will be storing a pair instead of an integer, and spelling for vector has to be correct. vector adj, let's call it, and n vector of pair in, yes, two things, and internally size is going to be 0, and yes, I don't think I have to write this pair thing like this, but okay. And then in left and right and C as in color for, let me increase the size for int I equals 0, I less than n minus 1, I plus plus, take in C in L R C and adj L dot push back, adj L dot push back up a pair of R and C color for this current edge, and adj R dot push back left and color. Okay, R dot push back color. Okay, now data is there. Long answer is going to be power n raised to the power of k with modulus n, and answer minus equals n. This is going to be our total answer, and then we will iterate through all the vertices, through all the edges, I less than n, I plus plus, and I messed up something here, which is I have to make these L and R 0 index, and as everything is going amazingly, blazingly fast. And now here we have to implement something, and we also need a visited array, visited a vector of bool, which is visited, or we can use a bit set. Bit set of size, what is the range? Const int range, const int range equals, what is the maximum value of n? I think it is 10 power 5 something, 10 power 5 exactly, to 1 1e5 plus 1, just for safe keeping. Size range, and we call it visited. Now if not visited, the current one, if I is not visited, then we will call the DFS algorithm on this one. What is it going to return? It is going to return the number of edges in this component. What if it returns 1? If it returns 1, then it is okay. Okay, it is okay. Int count equals DFS. I will call DFS on I, on the ith node, and I will pass in ADJ. Now, after that, everyone was happy. Now, what is going to be the function signature? Returns an integer called DFS. People call it DFS. It takes in a number n, the index of the node, and it takes in a very heavy thing called a vector of pairs of integers, two integers, and we call that adj, and it is generally a reference. Now adji is cnt equals cnt equals 0, and at the end we do something, and at the end we will return cnt plus 1, counting this current node and that. Yep. Now what do we do? Yes, we will call DFS int I or 2 x comma y or x comma c. C is the color and x is the new edge in adji, everything that I is connected to. First, I will see if it is visited or not. If not visited, x, if x is not visited, then let's process. Now, is this edge black? Not visited, and C has to be 0 because black, because we are only going to go through the nodes which are red. So x is also not visited, and x is also the edge that is connecting x to I is red. Happy. Okay. Then visited x equals true. Put x equals true and call DFS count plus equals DFS on x with ADJ. And after getting the count, we have to long a equals power. We have to, since C and T is the number of nodes in this component of only red things, what we will do is what we will do is we will take C and T to the power of k with modulus m, and then a minus equals C and T. Since there are total C and T number of nodes, and I need to find all the subsequences of size k, not subsequences, all the path, and a path is defined in this question, whatever it is defined like, and this is the way, and then we will subtract this from the answer minus equals a, and I think bit set is bit set. Okay, I have to include bit set, my bad. Bit set is not included. Yeah, bit set is not in. Okay, we are back. What are the other errors? Or maybe there are no other errors. Shit, minus. Okay, we messed up somewhere. Somewhere we did mess up. Somewhere we did mess up. But I think overall the answer should be right. Ah, shit. Okay. Sorry. This is wrong. This is wrong. This thing is, if it is not visited, I will make it visited. I equals. Okay, this is going to be correct. This is going to be correct. And this is going to be correct. Okay, everything is amazingly working now. Now we will submit this and we will see if this is correct or not. But before submitting, what I want to do is delete the whole code and let's see if we can write this again. So we are going to need some extra things. Const int m equals 1e9 plus 7, and const int range deranged equals, what is the range? 1e5 plus 1 at maximum, and we are going to use a bit set of size range. We'll call it visited, and then we will need a power function. And I think I have a snippet for power. Let me see. I think I have a snippet for power prime PBDS boilerplate. No, I do not have a snippet for power function. Okay, I will write it down. Int power takes in a and b and m, and if b equally, if not b, return 1, and then long answer is base a to the power of b by 2 with m. Take modulus with m, just just in case, and then do answer multiplied by equal to answer, and then take modulus of answer with m. Now if b was by any chance odd, then multiply answer by a and then take modulus of answer with m, and at the end return answer a and x, just like that. So the power function is done, and then I need the DFS function. DFS takes in index of a node I, and also that adjacency vector of pairs where both are numbered, ADJ, and this is going to be a reference so that everything is smooth. And then we will have int count initially equal to 0, and after some point the function will return count plus 1, and throughout for auto x and c, where x is the next vertex that ith vertex is connected to, and c is the color of the edge which is connecting the two. From adj I, if not visited, if x is not visited and color equals 0 and not c, if both of those things are true, we will do visited x equals true and count plus equals. We will call DFS on x with ADJ. So DFS is done. Then we need to fix this. And n equals n and k, two things, taken n and taken k. And then we will store all the data in a vector of in a matrix of pairs of integers. We will call it ADJ, and the size is going to be n. And internally, we'll have a vector initialize of size 0. I think that is good enough. Then for int I equals 0, I less than n minus 1, I plus plus, and uh, we will be taking in a left value, a right value, and the color for each edge, L, R, and then the color. And then we will do pushback, ADJ, pushback into L's list, pushback a pair where first is R and then the second thing is the color, and do the same for uh, R for the right thing, and do this. Okay, and then we will have long answer. Long answer equals power raise n to the power of k with a modulus of m. Okay, and then answer minus equals total number of nodes. Why? Because we discussed it earlier, I guess. And then for each node, and also we have to make these nodes 0 indexed, L minus minus R minus minus 6, Now we are going to traverse through all the nodes starting from 0, I less than n, I plus plus. If the current node is not visited, if not visited, if current node is not visited, then visited I equals true. Put I as visited and call DFS on I and get a not long, integer CNT, which is the number of nodes in this component which has only red edges. It is going to be DFS, called DFS on this ith node. And after that, our answer would be updated. We'll have we have to find all the possible paths of size k in this component of size C and T. So let's call this A will be equal to C and T raised to the power of k with a modulus of m, and then A minus equals the total number of nodes in this small component and subtract that from our answer. And then we will have our answer ANS. And then we check. Okay, it needs one more thing. It needs, I messed up, ADJ. Hopefully working. Everything is working. Let's submit and see if this is working. That was good. Hell yeah. Yep. This might. Answer is wrong at some point. Where, where? I think the logic at this point, I think it is like completely right. It is like bulletproof. All I needed was this one line. Let's find the number of bad sequences. That is all that was needed. I think the logic is bulletproof. There is no mistake in the logic. Is this function wrong? There is some implementation mistake. Maybe in this range, this much is like more than what is needed. This is way more than what is needed. And then if b equals 0, then return 1. Otherwise, raise a to the power of half of b with modulus m. Yes. Multiply answer by itself and take modulus m. This is always going to fit because answer is long. That is very good. Then take modulus with m, and if b was odd, then multiply a by itself, answer by a, and take modulus and then return answer. So this function is right. This function is right. There is no problem with this. There is no problem with this because before returning, whatever the case, we are taking modulus with m, and m is an integer. Sh- Shit. Since I'm taking modulus here, and then shit, okay, then I am raising CNT to power of something. No, CNT, Okay, this is okay. This is okay. This is okay. This is okay. Yes, CNT is going to be the number of nodes. That is not a modulus. That is just the number of nodes. And we are taking that to some power k, but we are taking modulus here. So this might be causing some modular arithmetic mistake. Mm, I think this might be causing some modular arithmetic mistake. Answer plus equals m and answer modulus m. If answer smaller than 0, this I think this might be cause. This might be it. This might be it. This might be it. This might be it. That might be it. Can we go past test 8? Okay, that was it. That uh, modular arithmetic. Modular arithmetics. S multiple shade. Yes. Okay. That is cool. That is cool. That is cool. And this bug, I would not have been able to figure this out if I hadn't watched Eric To's video on modular arithmetics. Ah, shit. Okay, that is cool. That is very cool. That is very cool. And I just want to do one thing at this point. Delete the whole code again and rewrite it. Just so I know I get this one. Okay, so what do we have? We have n and k. N is the number of vertices and k is the length of the path that we have to choose. So we take in n and we take in k. Then we will declare a data structure in which we are going to store everything, and it is going to be vector. It is going to be matrix of pairs, and this is how we define a matrix of pairs. We will call it adj, and there are going to be n rows and columns we will add as we go forward. So we just have to initialize pair int. Yeah, that is all which is needed. And now in each like entry, we will get three things: a left vertex, a right vertex, and a color. So for int I equals 0, I less than n minus 1, because there are going to be n minus 1 edges, and I plus plus. What we do is we take in L, we take in R, we take in C, and since L and R are 1 indexed, we want to make them 0 indexed, so we subtract 1 from them, and we will add them to our data structure of adjacency list dot push back. Say that L is connected to R and has the color C as the edge which is connecting the two, and R is also connected to L, and the color of the edge that is connecting the two is C. Now the total number of possibilities of path K. For that we will need a few extra things. One cons int m is 1e9 plus 7, the number with which we will be taking modulus, and second a power function, which takes in a and b and a number for modulating. Now we want to return a power b, So if not b, if b is 0, then just return 1 because a power 0 is 1. And otherwise, we will have long answer equals power. We will raise a to the power of b half on the behalf of a power b and take modulus m. And then we will multiply answer by itself and we will take answer modulus m. And then if b was odd, then we will do answer multiplied by a and answer modulus m. We can avoid this modulus, that is fine. And at the end, just return answer. And answer the total possibilities of all the paths is n power k modulus m. And answer subtract n, the number of edges, the number of paths in which we just do not move to any other vertex. We stay wherever we started from. And now we have to apply some graph traversal things for which we need a bit set of size range. What is the range? Const in range is 1e5 plus 1. And this is like pretty cool that we were able to do this. Yeah. There are going to be range number of things, and we will name this thing visited. And a DFS algorithm return, which will take in I, which is the index for some node, and also this behemoth of a data structure, this one, which is a matrix of pair, vector, vector, pair, in this ADJ, and a reference ADJ. Now, in CNT count initially is 0, and again we will return count plus 1, and we will now traverse through all the nodes which are connected to this ith node. For that, we will use this. X is the index of the node which is connected to this ith node, and C is the color of the edge which is connected in the two. ADJ I for everything that is connected to I. And if not visited X, if X is not visited and the color that is joining the two is red, red is depicted by C equals to 0. So if not C, which it would mean C equals 0. And if that is the case, then we will do visited X equals true and increase our count by the number of nodes which are connected to X. So DFS X ADJ. And yet, so CNT is all the components which are connected to all the X's which are valid, and plus 1 because we are also counting the node where we started from. And then we will do this for all the nodes for int I equals 0, I less than n, I plus plus, if the current node is not visited. If not visited I, then we will mark it as visited, I equals true, and we will have a number int CNT equals DFS for I. This returns the number of number of nodes in this component which has I as one of the members, where all the edges are red. And we will have our answer long A. Now we will calculate all the paths of size k which are in this component A, and it is going to be power A raised to k with modulus m and A minus equals CNT. Okay, did mess up. This has to be CNT. And then subtract from answer is, and now answer could be smaller than 0. So if answer is smaller than 0, then answer plus equals m, and answer, yes, answer plus equals m. Uh, Okay, this thing is apparently wrong. And that is also apparently wrong. Yes, of course. There has to be one more bracket here, angle bracket. We can submit this and see how well it is. It's been 3 hours and 42 minutes. That is higher than 3 hours and 30 minutes. Okay, and today we were only able to do one, two, three questions. 1 to 3 questions. But this was a good learning experience. Today was good. Today was good. Today was good. Because shit, the thing that was needed to solve this particular question was that instead of getting to the answer from zero to top, we could think about finding all the possible answers, valid plus invalid, and then subtracting all the invalid answers. That might be a better approach in some cases, which it is in this case. That yes, yep, sequences of length K that do not pass any black edges, then answer is all possible subsequences minus the number of bad sequences. Thus, we can remove black edges from the tree. Now the tree would split into connected components. The tree would split into connected components. For each connected component, if we start with AI being a node from this component, then we cannot step outside this component, since doing so would mean that we visit a black edge. But we can visit all the nodes in the current component in any order. So if the size of the current component is P, then we have KP. Bad sequences corresponding to this connected component, and the answer would be this thing. Yes. And I think we can avoid this thing here, and then also this part here, and still we would get the same answer, correct answer. Yep, yeah, that is cool. Yes, so sometimes starting from zero and only counting the valid answers might be too complicated, and instead we can start with the total number of answers, valid plus invalid, and then remove the invalid ones. And that is the whole thing. That is cool. Refresh. Edgy trees. What is the rank now? 310. It took us quite a bit of time. Editorial, help, and 1 hour and 13 minutes. 300. That is the rank. Among how many people are there? There are 100,000 people. No, 12,000. It's 121,000 people. Okay. Okay, and that would be it for today's stream. And thank you for being here. Bye.